ICOM Milano, joint stock company. Waste disposal, while respecting the environment in an intelligent way, is possible. ICOM Milano can do it. In compliance with the European law and the Ronchi Decree, this company has set up a waste processing method enabling the separation of the dry part of local organic refuse from the damp part. By so doing, the latter becomes hygienically standard and inoffensive by means of an effective chemical and physical system. It is known as the Orstab system. It obtained the patent MT95A001947 on September the 19th in 1995. The Orstab system can process up to 1,200 tons of refuse in its original state and can render inert about 800 tons daily of local solid refuse, which is relative only to the damp organic part. This is the best product of this joint stock company, ICOM Milano, which is located in Bresso in the district of Milan. It has more than 30 years of experience in the field of waste disposal. Moreover, it projects, builds and manages standard plants of local waste disposal, in conformity with the latest European and national law, which in the future will impose a process of refuse collection, as it is when it is collected, before their disposal by a plant or before their thermo-disposal by incinerators. The main features of the Orstab system that are at the basis of its success are its mobility, since it is made up of independent machines that move independently by means of wheels like trailers, and its use all over Italy, according to the authorization given by the Lombardy department. Its mobility is obviously linked to the swiftness of the waste disposal. The limited size of the plant is also striking. Its machines only need about 4,000 square meters and a height of at least 10 meters. What happens to refuse after being processed by the Orstab system? After the aggregation process, they can enrich lands, as they are made up of natural materials that can fertilize farming lands. They can also be used as coverage for controlled deposits, instead of the loam resulting from excavations. Finally, if mixed with natural mud, digested refuse can be utilized to reclaim degraded areas, playing in this way an important role in the field of environmental restoration. In order to reach the main aim of zeroing refuse inside waste disposal plants, the Orstab system has to be first put inside an integrated system of collection and disposal of local solid refuse, in compliance with the philosophy and the operating methods indicated by ICOM. According to the company in Bresso, waste disposal requires 5 different units, whose realization and working are at the basis of the Orstab system. Of the 5 units, 2, the second and the fifth one, are assigned to collect the dry part of refuse. In reality, 4 of the 5 units are sufficient to dispose and make the organic local refuse inert. However, according to ICOM, in the waste disposal process, the preliminary step of the collection is fundamentally based on the concepts of multi-bag and multi-bin. In order to collect refuse, ICOM uses a yellow bin or bag that has to collect any dry material, such as tins made of aluminium or iron, plastic containers, purified paper and cartons, wood and glass if not assigned to specific containers. A grey bin or bag dedicated to the remaining part, including the collection of films and plastic containers contaminated by organic refuse, multi-materials such as Tetra Pak, paper and cartons which are also contaminated, as well as household food wastes. A green bin or bag for the collection of selected greenery such as cuttings coming from grass, leaves and small plants. Let's now see the Orstab system at work, ready to daily dispose of 300 tons of local organic refuse, in a model town of 250,000 inhabitants. Let's try to follow the scheme of the different units, starting from the aforementioned data. The local settlement under examination produces daily 1 kilo and 200 grams of organic local refuse per capita, together with 0.12 kilograms daily of green recyclable refuse. As a matter of fact, Unit 1 is a plant similar to the Orstab system, since it treats 225 tons daily, thus receiving the biggest quantity of material, and it can dispose of the damp waste, known also as the remaining part. This fraction comes from the selection of the material that has been divided from the dry part of the local organic refuse, and has been collected in a specific grey bag or bin. This plant disposes of a large quantity of refuse, as we previously said, from polystyrene to transparent small basins, from glasses and plastic dishes to yogurt containers, from packing films to plastic bags, as well as all the cooking leftovers. Moreover, there are shoes, tights, rubber, Tetra Pak containers from milk and juices, as well as any other multi-material such as paper and cartons, cloths and clothes if contaminated by organic refuse. This Unit 1 is composed of a weighing tool, an area where the material is stored to check its quality, an automatic or semi-automatic charging hopper system, a first grinding machine and/or bag ripping machine, a magnetic metal detector to select the first ferrous parts, a first revolving screen which is able to select the dry part bigger than 80 millimeters, which in turn will be delivered to the specific dry waste disposal, a second revolving screen which is able to select the dry and thin part having a diameter of 40 millimeters, which will also be treated by a specific unit, a mixer, the heart of this plant mixing and aggregating the organic material into additive compounds such as lime and Orstab 50-100, a second magnetic metal detector to select the second fairest and finer parts, a third and last revolving screen for the final check of the product to select the dry part over 80 millimeters. It will also be delivered to the specific disposal unit treating dry refuse, which reach a daily total of 140 tons. A storage area enabling the stock turn of the final product in order to respect the time necessary to complete the process that makes it hygienic, stable and inoffensive. Quality check of the daily 45 tons of waste mixed with lime obtained by this process before the final destination. Images show a phase of the work carried out by an Orstab system plant. This is exactly Unit 1. ICOM Milano has projected and set it up into a disposal belonging to the consortium Caserta 4, between communes in the province of Caserta. In this plant, as these images show, the screening is carried out just after the grinding phase. However, two different types of revolving screen do not carry it out, as we previously said. Only the screen containing some holes of 40 millimeters carries out this working phase, because this particular part has been projected and built for the disposal of the organic part of the waste, which has already been mechanically pre-processed in another plant. Unit 2 is a plant linked to Unit 1 by the dry waste disposal that can't be recycled by producing fuel from wastes. As we pointed out, this plant receives the dry part refined by Unit 1. The treated material by Unit 2 is treated according to some detailed working phases and some specific machines. A magnetic metal detector collecting any ferrous metals if they still exist. A diamagnetic metal detector taking away any metal that isn't ferrous, like aluminium. A revolving screen to select the resulting organic part that has to be sent back to Unit 1, thus obtaining an extremely clean and homogeneous dry part. A storage tank for this section. A fine grinding machine to grind and refine the material. A distributing tank and emergency tank. A heating tunnel of 100 degrees centigrade. A calendar leveling the product, a longitudinal cutting machine, a cooling process, a waste compressing machine, a storage tank for the final product containing 120 tons daily, a packaging machine, a storage area sheltering the material before its final distribution to cement factories, power plants, teleheating, Unit 3 is a plant developing the selection of the recyclable dry part of the local solid waste, coming from the selected refuse collection into an appointed yellow bin or bag. Inside this plant are stored all the materials that are not contaminated by organic refuse: paper and cartons, cellulose products such as newspapers and magazines, tins made of aluminium, cans or tins made of any other metal, plastic bottles. The model considered in the example shows a quantity amounting to 75 tons daily of dry selected refuse. Even in this unit, there are a weighing phase of the material as it arrives, then there are storage and quality checks, an automatic or semi-automatic charging hopper system. After this operation, a first machine enables bag cutting and a first reduction of the product, a possible grinding phase of the bulky material, a screen to eliminate dust and any organic refuse which has to be conveyed to Unit 1. The real selection process, by manual sifting of any potentially reusable material, is carried out by some operators located in the appointed cab and trained to divide paper and cellulose products from carton as well as PVC containers for liquids from PET bottles. Once divided, all these materials are conveyed singularly and automatically to the roller compressing machine, thus turning the different materials into bales and enabling a better storage before their dispatch to the Conai threaders. The material still on the selection belt is automatically divided from any ferrous material by means of a magnetic metal detector and any light metal such as aluminium. A diamagnetic metal detector carries out the latter process. Hence, the last products which are obtained are distributed to Conai. Totally, about 67 tons daily of material will be parted and distinguished. The resulting residue, more or less 8 tons daily, is sent to Units 2 and 5. Images show exactly Unit 3 while operating. It is the plant of the first treatment and storage of the materials resulting from the selected refuse collection of Tarentum, which ICOM Milano has realized after a public auction. Unit 4 is a plant disposing of the organic part, which has been selected from the local solid refuse, resulting from the selected collection into some appointed green bins. The collected materials are grass cuttings, plant cuttings, selected products concerning meat or vegetables coming from markets, meat trimmings from butchers, as well as selected fish tailings from fish markets, thus reaching a total of 30 tons daily. The working steps are weighing, quality control, an automatic or semi-automatic charging hopper system, a possible mixing with cellulose products, the aggregation of additive compounds through a chemical and biological process by adding the alpha amino acids, lactobacillus and urea, the composition of a new compost that will be a natural fertilizer, the use of the fertilizer so obtained for farming lands amounting to an extent of 15 tons daily. As we said with regards to Unit 2, the dry material that has been parted from the local organic refuse can be used to produce waste fuel if there are disposal agreements with cement factories or thermal plants. Moreover, it can be employed to supply power. Unit 5 is in fact a plant connected to Unit 1 for the low temperature gasification of the separated dry solid urban refuse, also called thermolysis or pyrolysis, with the use of tech trade technology and the production of electric energy. A plasma torch with RWH technology can be connected to the plant for the vitrification of the ashes produced by the burnt gases. Unit 5 receives the dry part separated from Unit 1, amounting to 140 tons of daily waste. It carries out a magnetic detection of any possible ferrous fraction, together with a diamagnetic separation for the non-ferrous metals. Then it follows the grinding phase by means of a grinding machine using knives. Thus, the material obtained is conveyed to a storage pit, from which it is directly loaded into the furnace drums. Low temperature gasification takes place here. It leaves a residue whose energy content can be recouped even further in subsequent combustions. The gases produced by pyrolysis are filtered by means of cyclones or ceramic candles, while the dust particles are so weakened that they are subject to the same treatment as the solid residue. At this point, the remaining part goes through a combustion chamber at an extremely high temperature, 1000 degrees centigrade. From this combustion, steam is extracted by means of a boiler. The steam can produce up to 5 megawatts of electric energy, thanks to the use of a turbo generator. An appropriate purification system makes sure the fumes produced by the combustion are eliminated. The rejected parts, amounting to about 35 tons a day, can be destined for vitrification by means of a plasma torch, or can be stocked in a supervised deposit. These proceedings could seem complex. However, the technical and human effort supplied by ICOM Milano grant a swift and effective waste disposal according to the latest laws. It is a new frontier that ICOM, thanks to its know-how and technologies, has reached and surpassed with the respect of both the environment and quality.